So one is very relaxed, one is with people we know and you and know. So topic today is on artificial intelligence and vision for India. I will try to lay down a vision which is very different from what is being talked about. This vision I also presented to Parliamentary Committee on Education when they are preparing a document, policy document for what AI needs in for education. So being of course research technology, and this talk is not directly on education but how research and technology development, what kind of work needs to be done to build AI for India. And one of the core things I want to emphasize is that today AI is largely based on data. However, knowledge is a very important part which must be incorporated in AI systems, which is currently not being incorporated. So as we move forward, incorporating knowledge will be important. What that means is if you are building an AI system for chemical related to groundwater, related to plant diseases or anything else, you will require the domain knowledge. And that knowledge will be used and will be very important. In this, I straight away jump into the talk. So clearly, AI has caught the imagination of our people. Our people tend to be very excited without understanding. So our job as technologists is to educate. We have to understand that this technology needs to be handled very carefully. If we try and incorporate new approaches, effect can be sweeping without harming, without having large negative effects. But we have to be careful in how we use AI and what purpose we use, how we develop it, how we control it. So all these elements will be there. Some of the things we discuss as we, and leave for discussion. So I'll talk about IT outsourcing industry for a minute. That's an example of what happened there. The past is always an important guide for future. And I take example from Mission Vashini of what was done. And I'll talk about crowdsourcing. No, not crowdsourcing, community sourcing. And what we can do to prepare our people, our students, our faculty, our teachers in schools. So let's start with IT outsourcing. Now, IT outsourcing idea started actually in the 1990s. And TCS people will say even earlier. But offshore outsourcing started in late 1990s when the internet arrived. And it opened up a new vista for India. It was great success in some ways. It generated a lot of enthusiasm in the country. It also generated revenue for government. But we will also see that we do not develop products, IT products that will go worldwide, even though our outsourcing services went worldwide. And the question to ask is why? So, by no means I am saying this is a failure, this is a successful thing, but for an assessment, we should be able to say what was the strength and what was the weakness. Where we were successful and where we were not. Even though overall it had a positive impact on many things. It also had negative impact, but we focus now on the technology part. Now, why were we not able to build products? Now, products develop when you actually do work, various kinds. So, if it's the case of software, then software services lead to building of various, software systems, but they are not products. They can't be reused everywhere. So, the products come up when you abstract out your experience and you say now, with this abstraction, I'm going to build a piece of software which will become useful in many, many ways. So that kind of product sometimes, so this requires, so of course, why do you want to abstract out so that you can reuse it and you can solve various other requirements, software requirements, and that are coming down from the market or society. Now the reason IT outsourcing industry could not do this, not that it didn't try, it tried but just didn't work. And the reason was, it was far away from the markets for which it was providing services. It was providing services to the Western markets, and it was far away. So it did not know what the market wanted, what the needs were, and how to fulfill them by abstracting out ideas. So one prime reason why this could not be done, because we were at a distance from markets. We did not know what the requirements are, how the requirements are changing, what new requirements are likely to come. Now, if you are close to the market, you become aware of all this. So the question to ask is, in the case of artificial intelligence, can we do it differently this time? Can we actually build AI products? So let us look at AI systems. So I think I didn't expect it frankly, that AI will become such a reach. So, but it has. And when that happens, one can then say, all right, we use this opportunity to set things right and to begin with the right earnest and with right problems with right time. So before we answer that question, how to build markets or be close to the market. So first, some properties of AI systems. So first thing is, AI systems are contextual. Even after you develop a system, you run it against benchmarks, you show it is working with 88.3% accuracy. When you go and take it, apply it in real life, you find it doesn't work. 88.3 has become 59.7 accuracy, as good as useless. I like to take so some people have started thinking, so our India sort of runs on bandwagons. And bandwagons make a difference to understand what needs to be done. So first of all, people think AI is a turnkey technology. What is a turnkey technology? You turn the key and drive away. What would you do if you wanted to buy a car? Go to the showroom, to show you all the specs, colors, seats. You see, after that you pay the money, he hands you all the key. Go ahead. You turn the key, only thing you need to know is driving. After that you go. Job is done. But when you reach home, last 1 kilometer there is sand. You can't drive now on sand. So what do? You go back to the showroom and say, the car doesn't drive up to my home. He said, oh, what's wrong? He said, no, there is sand. He said, please talk to your MLA or MP, get the road built. He says, no, but isn't there any other solution? No, it's not my problem. You go to a place, but that building of that road will take now 20 years or 10 years. So what do you do? So you go to an innovative mechanic and say, yes, I can modify your car that will drive on sand. Because I have to change the width of the tires. This will be extra thick tires. And of course, the engine, you should have bought a little more powerful engine car. But it will do. So whatever you have bought, whatever technology you have, you try to modify it. So it's okay, please go ahead and do it. So if design says works out the cost, say no, this is too costly. Say, but this is what I will require. This is the money required because I am also, this will take time. Everything I have to hand build, and this is what is needed. So what do you do? So AI technology is in that situation. Like to give this example, real example. When Bhashini work was going on for speech recognizer, means speech to text. This was being done at IIT Madras, and they did their recognizer for Indian English. We compared it with Google, which is available at that time. It is about 3 years old. So the accuracy of Google was 87, and the accuracy of the system they have built was 85%. Word accuracy. Mainly, you take the speech, you transcribe it perfectly, and now you ask the machine to do it and compare the perfect transcription with what the machine is producing. And if a word is wrong spelling or wrong word, you mark it as wrong and count percentage. Right? Now this is we take NPTEL lectures and do speech recognition or NPTEL lectures. So when you pick some engineering lecture, it was mechanical engineering. They tried it. Accuracy of Google went 5 to 60%. It's like the car that you bought. Okay, runs fine, but when you want to use it, it's as good as useless. With 60% accuracy, it is easier to add ratio type by hand rather than correcting errors when every alternate word is wrong. Okay. What happened to their IIT Madras system? Went to 80%. Why? Because it was trained on that data. They trained it. They added that data for training, and it went to 88%. So AI systems are not turnkey systems. Once the company claims it works, then you will find that lot of tuning, etc. will need to be done. The large language models have suddenly caught the world by storm because they produce summaries which are very, look very good. However, they are wrong at times, hallucinations also. But whether that summary is adequate for your purpose, whether it has errors, those things will have to be evaluated by you. But if you go to predictive AI system, then things are not so good. Second, if you want to build AI systems for India, it should be based on data. If you want to build Bhashini for Indian languages, you have to require data for Indian languages. If you want to do prediction about weather, you should have data about Indian situation. Okay. So data is largely missing in the Indian context. Whatever data is there, usually it is logged up, not easily or not available. So we should be aware that AI systems are contextual and that for building AI systems for India, we will need to have generate data, collect data, get access to data. I take the example of Mission Bhashini. It's starting because I call this the first AI mission of India. And believe it or not, I handed over charge here, and almost the next day, the next month, I get a phone call from the Prime Minister's Council for Science and Technology and Innovation, saying we want a translation system to be built by us, and we want to launch a mission which can translate among Indian languages. And the task which they said was that build it for English to Indian languages for science and technology material. So that was the task. And they said, can you design a mission which can then run? So at that time I said, what should be the scope of this project? I said, at that time, we are thinking of the mission, national mission. Let us be more ambitious, let us dream. So we will not just build a text-to-text system, we will build a speech-to-speech system. And you get text-to-text as part of building such a speech-to-speech. So I think the scope will be that. And of course, this required preparing the plan, preparing the broad white paper if you wish, and presenting it to the council, and then they accepted, they agreed, okay, yes, we should go ahead with speech to speech. Of course, while building a speech to speech translation system, you can think that there will be three major components. There will be a speech recognizer. So if somebody is speaking English, of course, I say it will be for all 22 official Indian languages and English. So that is what we should aim for. Not just translate from English to Indian languages, but also among Indian languages. So that scope, I stressed it, and fortunately the council agreed that yes, this can be done. But we asked, can this really be done? Aren't we trying something that won't work? Then the risk is one stage. And there's a good chance that it will work. Of course, we also organized a meeting of researchers in machine translation, text-to-text translation, and researchers in speech technology. And in that meeting, the two groups came together, and I told them this is a challenge, it's a national challenge, and I will lead it. Today, you may feel, what's big deal? Because this technology has come. But at that time, it wasn't there. There was speech recognition, there was text-to-text system, but there was no speech-to-speech. So, of course, one purpose of a mission is there is word now being used, AI sovereignty. And the AI Impact Summit that was held in February, it meant building our own data centers. We need our own data centers, but we need our own technology. Full power over the technology. So, technology sovereignty is the key element today, as we understand. The other parts we can build, the data center, the machine, computer infrastructure, those things we can get. But technology-wise, we should be good. This control over technology is needed for another reason. Simply, that AI is contextual. So if you get AI technology for some task, it will need to be customized, it will need to be adapted, it will need to be changed. And you can do that only if you have control over it. Key ideas in this, people use consortium approach. Building a brand new technology, which is not very clear it can be built. So this technology was built by 70 research groups working together. 70 research groups, 70 research groups. All homegrown, completely with full control. We know every line, every circuit, and what needs to be done, what algorithm for machine learning to use for this task, for the other task, and so on. But how do you coordinate among 70 research groups? So we form actually 8 consortium. One consortium will have several research groups working on some common problem. So, for example, speech synthesis or speech analysis, text to speech or speech to text, they will be consortium. Then machine translation, separate consortium. There was also a group working on Sanskrit and using that for building, doing research, how we can use those ideas for future systems. May not be easy. There was also data creation, data collection. So all that was done through consortium. We also plan for acceleration centers. And the idea of acceleration center is after the technology is developed, then it has to go for use. That is where you require to fix. So academic centers do research and develop technology. Acceleration centers in the incubation center associated with the software part, technology part, with the academic institutions, the non-profit, they do scale up and they do domain adaptation. The first level of AI adaptation for the domain is done by the acceleration center. And this then goes into startups. And they use this technology and to serve customers' needs. And this is whatever extra needs to be done, extra interfaces, even planning, machine learning, all that they can do. Acceleration center will come up here. So far in Vishal Bhashi, although this was planned. So one central acceleration center now, and the central things don't work. Because the requirements are distributed, the needs are distributed, how will one center do everything? So, during COVID, so from here I went back to like the Hyderabad back. And when COVID had come, I went back as a faculty, not director. And there was a need to teach the course because of COVID, the students were at their homes. So labs could not run. So for first year, how would you run an electronics lab? Computing lab you could do something, but electronics lab you can't. So the institute decided that we run a special course on history of computing. And I taught that course online. There were no students. They were all at home watching these lectures. And In common perception was that computer was built by Google. It was 2020. AI has not yet burst on the scene. So how little our students know about our own field, how we are involved. And pardon me, even our faculty doesn't know. That I found, of course, they are not saying Google built everything, but what were the processes? I remember in that course, the then director at IIIT and I, two of us brought it together. So we said, let's start with the cell phone. So we showed a chip with 1 billion transistors. It had just come at that. And said, how do you think this chip has come? This is your cell phone, and your cell phone has various technologies which are working inside, working together. The chip itself has 1 billion transistors. But then if you look at the thing, then hardware, software, how the separation. So I taught that part. And so how hardware and software got separated. Earlier, you bought a piece of hardware, software came for free. That's how IBM would work. But then there were some problems, so IBM, when it brought out its PC in 1981, it said we separate out software, let it be developed by somebody else. We gave that to Microsoft, which was a small company. And from then on, software was priced separately. So there are various elements that go. And where 1981 means that we started actually in 1972, when the first microprocessor. And what led to the proliferation, the spread of that knowledge. And there were hobbyist clubs all over America who were using that. There were kits that were created for building things. These are tiny kits, hardly useful for anything. But people bought them saying, oh, this will be fun. This will be a toy that you play. And then these small S100 bus subsystems were built, which came up as part of hobbyist network. So it developed a community of people who started understanding, and that community spread in large numbers, lakhs of people, unlike thousands of scholars. But lakhs of people, ordinary people, but sometimes, yes, there were engineers who were learning this new technology. Remember earlier engineers were either electronic engineers or software engineers. But these people were working the things together. So this guys, it occurred to me that this sociological process, and this process led to, there is a need to understand that process. So when we are talking about AI is not going to be dropped on us from heaven. We have to develop it from ground up. Then how do we build an ecosystem? An ecosystem in which there is technology, in which there is hobbies, in which there are people with free software. I'm giving you examples from there, but corresponding things for AI. And as I will tell you later, this word ecosystem is not enough. We need to talk about ecosphere. Ecosystem tells you everything is systematized. But in sphere, like biosphere, it's not a biosystem. Biosphere is much larger than the systems that we understand. In the case of building an AI system, the ecosphere will be much larger. So I'll talk about the ecosphere today. Maybe speed up a little bit. So I'll talk about community sourcing, building an ecosphere, involving lakhs of people, and most importantly, our students. Few students are sitting here. Let us think. We should become not just consumers of technology, we should become producers of technology. And that technology that we need will be developed by us, not by anybody else. So let me straight away jump into community sourcing and then I'll talk to the vision for data. We need to move from crowdsourcing to community sourcing. Communities of people contributing, producing technology. And this would mean students from schools as well as colleges. Take up local problems, relate with the subjects that the children are studying, collect local data, could be done best, could be done by school students in class number, algorithm development by technical people, students in colleges, and building systems and tools. So I'll give one example, straight away, jump into some examples. Take the example of groundwater prediction. So prediction about, so if I live in a village, I'm a farmer. Even if I'm not a farmer, I live there, I want to know what will be the status of water. You get the water crisis. I will do some crafts or craftsmanship. I will go what to need for water and even just for living. So if you want to build a prediction system about groundwater levels, you require meteorological data, conditions on local ponds and lakes which can be measured, local usage patterns of the water, how they are changing entirely, what is the usage pattern in what areas the water is being used, crops planted, their water requirements, because that will determine the usage pattern for as far as water is concerned. Now if you use all this, okay, we would need to have data about it. Meteorological data we can get from the weather service for our region, our smaller area. But other things, we have to gather that data. And if we gather this data and put it into an AI system, then it will start giving us predictions. And my claim is that that prediction will be superior to any other large-scale regional prediction. Why is that? Because certain elements which are larger systems, of course I can use that data, but the other things are all local. So if I can get that local data, let's say about the surrounding 10 villages, now that will be very valuable. And that data can be used for making predictions. So if I build an AI system using for local problems, I need local data and my prediction will be superior. In evolution, this problem comes up that once a more stronger species comes in, why doesn't it displace all other species? Once the lion has come, all the other lower animals is going to be up. No, it doesn't have. Why? What we have learned in evolution is there are evolutionary niches. There are ecological niches. Niche means a smaller space in which that other species has an advantage. And that species actually thrives. In fact, indeed, these large, powerful species are actually quite fragile. If something goes wrong, which is the first species in the forest which gets finished off, we will protect tiger. If you save the tiger, it will be finished off. So, if you realize this, then technology-wise, we should find technological niches, no matter how large the technological big companies, multinational companies, how big they are, how strong they are, in that niche, you can defeat. This was the model I used when designing BHU. Now, by the way, BHU technologically is a success. So we said we will build technology for 22 official languages. We built it for 36 languages. 22 plus another 14. 22 plus English, but it is 35 plus 1. So another 14 languages, including those two. Solutions for speech, text-to-text, speech-to-speech, there are lesser number, but the work is good. And this technology was transferred for scale-up. So BHU systems are running today with 50 million inferences per day. There is an app, BHU app. You can download it on your mobile. You go to Google and say BHU, download the app, and you will be able to translate speech to speech from Indian language. Speak to it in Bengali, and it will produce Marathi. And this work is done completely by Indian academia. IIT BHU also has part of a project. Sukuda is AI for that one. Now, what we need to do is to look at our problems, solve them, and be masters in that area. That will be mission. Let's pick one more example. Yeah, before going to the next example, collect our data related. So, if school children can do it, it is the task that is attached with the school children, where they are studying geography, they are studying biology, they are studying mathematics, area of not just a triangle but something more, pentagon and all that. So they would learn how to fit a pentagon on a lake and compute the area. Okay. So the major problem that we have that most of our education is bookish. Children learn from the book, solve the problem from the book. They think it has nothing to do with real. Now this is a way to link real life with the book, which I call theory and practice. Both are important. So this data could be collected as part of school projects, a geography project, or a biology project. Sometimes the two together interdisciplinary, right at school level. To collect this data, they algorithm and they upload it into this data will belong to us, not to multinational. And then apply algorithms, packages to gather data. This will be done by IIT BHU students. They will pick up such projects, civil engineering, and chemical engineering, metallurgy, biomedical, biochemical. There is scope for doing this. And in this, you will be connecting children in schools with their books, real life with books. And the system will improve over the years as data builds up, even better as it is get. Now, one problem with AI currently, so I've been in AI for 40 years, believe it or not. So I came back from US in 1982, joined Kanpur, working in AI, so I said I'll choose now problem, Indian problem. I've done work on American problems, but I'll work now with Indian problems. I kept aside all that other work on knowledge representation, on specification languages. And now I work on Indian problems. That language appealed to me for some reason. So I said I'll work on Indian language. And I've seen, so, and that work started in 1983, 82, 83. Big back in 82, 83 onwards I have been working on. So what I found was that AI has undergone, three epochs, three major changes. The first epoch was knowledge-based, rule-based. The second epoch was statistics, statistical-based AI. These two epochs could merge with each other very well. So, in language processing, we were building a system in the 90s using statistical processing and rule-based processing together. 2016 onwards, the third epoch started based on artificial neural networks. Then you do not know what the machine has learned, how it has learned, where it has learned. It's a black box. And in that approach, AI is anti-knowledge. I don't need your knowledge, just give me data, nothing more. This is a mistake. Problem with our people, we are bandwagon people. We just sit on the bandwagon and say, go wherever the bandwagon is going. The bandwagon is going to fall in a ditch, you find out after you have fallen in the ditch. I believe that knowledge will play a very important role in building AI systems of the future. Which means, we are talking about groundwater. We will not talk about evaporation. When you figure out, when you get the meteorological data, so many sunny days, would you be able to say what will be the rate of evaporation of the water bodies? About how the water percolates in the soil? And knowledge is there. But AI system would say, no, give me data only. Now, once the data becomes extremely large, then somehow this approach is working. But this approach has other problems which I won't talk about today. But when the data is less, then knowledge is critically needed. Then knowledge is needed for sure. Even in machining, we are using knowledge as several formats. And in part of speech tagging, we are incorporating it in prosody, putting it in discourse analysis. These are not knowledge things. Because we translate not individual sentences, we translate the or entire text. So knowledge comes in crucially. So whether you are in mechanical engineering or civil engineering or physics or chemistry, knowledge is going to come in. Now or later. But when you are talking about smaller amounts of data, local systems, knowledge will be crucial. Which means entire research is open to us. What algorithms? Algorithms that can use the knowledge, not just the data. The whole field is open. Just like statistical and knowledge-based systems of the earlier kind marry each other. Modern artificial neural network-based systems will not work unless we also put in knowledge. Okay? In case of critical systems, knowledge is actually crucial. But I won't talk about that. There isn't enough time. So let's go on. Another example I selected content creation in Indian languages. So how can children in schools create content? Why schools? Why not in colleges? We could prepare content pertaining to India, original content in Indian languages, local history, stories, social studies, or translating existing content into Indian language. This will be primarily informational content. Information is there in English about Indian situation, and translate it, make it available to people. And this will be posted on Wikipedia or some other commonly used platforms. The translated content will also help with the purpose for creating better translations. Just like we collect data from the groundwater prediction, over the years it will become corpus, it will become training data for future. Of course, if you talk of less resource languages, where there isn't that much spoken data or written text, they would certainly be benefited with the use of knowledge. History of an area, collecting stories of people, what place other than Varanasi, it's the stories of the civilization, if I may say. Collecting stories, which are the folk-age, grandmother stories, all that can be part of. So we call, this is more. Such efforts can also be encouraged. Contests can be organized at district level, even at the city level. You take 20 schools, some of those schools create data about language. You can take 10 schools in the nearby villages where they become a specific project pertaining to groundwater or about plant diseases, the early detection, the early treatment. Or you can talk about pollution, chemical engineering analysis, what kind of data is there. So what samples come, based on that you make predictions about what is happening. And the good part is education makes a huge difference. Education which is bookish, uninteresting, suddenly takes on a different shape. So it has that. And students, when they see their working systems being used, it produces a different kind and different level of satisfaction. Not just rewards, awards, but also the fact itself that my system is working. Road monitoring, repair planning, based on photographs, image analysis of photographs, various things can be done. And you are better than discovering these problems related to energy, related to water, transport, health, railways, roadways, and what else. So, you could start with 1,000 schools if you're doing it in a state and also. And the children, the students who do this, they feel like, I have done it, so I can be an independent. So there can be incubation schemes, IDAP, and so on, where you can take local talent, encourage them, provide technical know-how to make their systems better, and unleash the social energy of positivity. It's like building not just an ecosystem, an ecosphere. Where communities join it, that's the ecosphere. Not the ecosystem doesn't capture the richness that comes in when we talk about ecosphere. Of course, there are three effects of AI, the education and otherwise. So a lot of people would have talked about it, we are reading a lot about it. So I will simply this time, then I will, or maybe I'll just read them out and prediction showing this is what children are having isolation from each other, like interpersonal problems, mental health issues. We have to deal with them to education. This is my firm belief. It is the education that has to solve these problems. Right? Starting from schools. And teacher's role is getting transformed, as you would have been finding out yourself. It's not enough to be a lecturer lecturing to students. It will not become a mentor. The problem where the student is having difficulty understanding your concepts that you have taught, you have to address that. That is what lots of people are saying, AI will do this. I don't think AI will be able to do it. But remember that this is one area where they say AI will provide personalized help to the student. But it is a teacher who has to, I agree, it is a teacher who has to play that. And for doing it, you have to find innovative ways. Peer learning, build learning communities, learning groups. If you have a class of 200 students, form groups. Form groups of 4 students. You have 50 groups, you have 50 students within. They help each other in each group. So when they say this I didn't understand, those 4 people are saying I couldn't figure it. You become their member. So you have to create creative ways by which you are able to address personalized problems that the students face. And this I always say, if you go beyond your subject, where I said human values, you're actually going beyond your subject. Education is not just one subject. So you have to be a friend to love your students. When you love the student, then you feel a connect. You want to help the student. And that philosopher means you take up not just a specific problem that is at the surface that the student is asking, but much larger. That larger thing when comes in, it's not related to just any one subject. And at least my attempt was through humanities, social science, and enlarge that understanding. And then human values becomes the case. But I believe that in the race for NIRS and rankings and points, we have listed education. I'm friendly. To find ways to overcome it. And some of you have to come forward and say, I'm going to do it. Doesn't matter if my promotion is today. If I'm only focused on my promotion, my points, I'm not doing justice to my job. So teaching becomes very, very important along with research. And that teaching is no longer just teaching. Teaching is mentoring. And being a friend, philosopher, and and of course at individual level, but also at the system level. Create an environment, not just at the individual level, but in the institute level, department level. If I was introduced these lead business, it took time to lead produce where we connect with students and the teacher training faculty development program, and not just faculty but the school teacher training program, where the school teachers become mentors. They ask data collection, connectivity to real life, but being a mentor. The whole thing is that students should learn to become givers, not just consumers. India should learn to become a giver, not just a consumer. And give to whom? Give to ourselves. Which areas? But yes, it may not come to me directly myself, it may go to my other competitors. So that is the goal. And human values person have been trying to put results wherever it has got. There are people have taken serious interest in it. And so the time has come for a rethink, major rethink about it. Major in both school level as well as higher level. Arrival of AI is the time of change in education. We need to use AI wisely. with local AI systems, data and technology. Varanasi is an example of how it was done, but now how to incorporate next 200 languages just in Bhashan business. India has something like 900 languages. So, you want to add 200 more languages, it will all be done locally. And of course, prepare teachers and students in schools and colleges and create the entire environment. Thank you.
I'm sure you all will agree with me that it was a wonderful and insightful lecture and thought-provoking. What you think and what Professor Sangal has conveyed his views, his vision about AI, I think that will give us a take-home message. But at the same time, as he is really available to take some questions, comments, suggestions, so maybe we can spend another 15 or 10 minutes.
Yes.
Yeah, we can spend 10 minutes from students, teachers, faculty, please, if you have any questions, suggestions, comments, come forward. Thank you. Somebody should start.
I can go take the mic.
Yeah.
The mic.
Thank you, sir, for the presentation. I really enjoyed this presentation. Many of the things were not very clear in my mind. One of the things, because first at the start of the lecture, we talked about the Indian companies, they don't go for product software companies. There I thought that my perception is, my thinking, my understanding is that while they opened their offices in New York, Washington, whatever countries and all other countries as well, but they never ventured out. That is, they were playing safe. They were only going for B2B, not for B2C. B2C is always riskier because you have to do a market survey and take the risk of whether the consumer will like the product or not. So they did not take the risk. That is my thinking. The second thing is that about use of AI in education, especially for children and adults. What my understanding right now is that it is definitely affecting for smaller children, especially like say class 6, 7, 8, 9, like that, and who are exposed to this mobile technology and other places where they can very easily use ChatGPT and other accessible softwares. Then what happens is that they just putting all the questions over there and get some answer over there, and just putting a copy paste. Now it good or bad or something like that, the point is that
Because of shortage of time,
yeah. So I will just come
only
to
one slide of that.
Yes.
We can avoid that because you keep hearing this, what you are saying. And if people use ChatGPT, they will not learn anything, etc. Let's forget that because that part is right.
okay.
I agree with you.
So I will just summarize that. Yes, I believe that, and I think most of us think and understand that it is affecting the cognitive ability for the human. So that is my comment and.
So in industry, you must be a question that you ask. I know of several attempts by Indian companies which are trying to build products. One problem was that when they are building or planning that product, some crucial thing is missing. Why? Because they don't know the market is America or Europe. So they were not able to place their product. And yes, it was risky for sure. So only a smaller number of companies tried it. But those who did also didn't succeed. And primarily it was the distance from the market. So there were people who were willing to fund that. After let's say first 10 years, when the industry had money also, it did not work. Of course, there are other reasons, it's more risky. So, but if you are doing it for Indian market, Delhi, for example, became successful because they built it for Indian market. And once you are close to the market, you know what is needed, what is required. You do that.
Yeah, please. Thank you for for very interesting and insights into what we are doing right now. And I want to raise this one point about the main competitions that we should be focusing on. Which actually discussed on data knowledge. So I find that it's also important to identify something related to creation of creativity. It's not just a kind of systemic work that creativity represents. That's not it also. I think it's already played a crucial, not exactly AI, but the internet has already played a crucial role in actually opening up that space of creativity. One example, if I go from this, would be like a lot of work sociological was done on this. There were a number of media posts that came during the COVID time, when from isolated pockets people were actually post individual stories, narratives. The question is
So, first of all, when we work with real life problems, then we do not be bound by boundaries, disciplinary boundaries, because real life problem comes the way. You can't say, I will analyze the physics of water but not the chemistry of water. But it will not work. So the problem itself forces you to cross the boundaries of knowledge. And then that naturally makes you creative. You have to solve problems which you have not solved. Creativity comes for free. You become more creative because you are forced. So happily, this is a situation where knowledge and creativity come together.
Good evening, sir. I don't know whether it's related to this talk or not, but I want to have it very like this that nowadays many young students as well as the early faculty members they are using various tools of AI like ChatGPT and so on to write the research papers. So in this regard, I want your opinion about the same, especially what you want to put with the message, especially to the researchers as well as the other faculty members.
So what do you want me to say? So I believe that if you're talking about research scholars, we learn by doing things also. I gave an example the other day. Some people say, look here, once the calculators came, there was no need to learn tables. What's wrong with it? So I said, even though calculators came, you still have to learn about multiplication. What is the concept of multiplication? Where can I use it? Where can I not use it? So that conceptual understanding is needed. The other part is communication. So how to communicate this? Now that I must learn. And communication is an art. You have to take it take somebody from where the current thoughts are and take from that point to where you want to convey some new information. So that is a path. Now, large language models, they produce very good summaries, etc. by looking at known text, trillion tokens of text. But that doesn't work when you are wanting to convey something from your point of view. And if you are a student and research scholar, you want to learn how to,
Yes.
you want to learn how to communicate, how to take a reader from where he or she is to your point. So very clearly, you will need to learn that art. You have to learn the science part of it also. So naturally, you will need to learn all. Okay? AI can be a tool as well. So use it as a tool, but to be able to use that tool, you better know the stuff, know the fundamentals, know the art of communication, know your audience, and whether this way of doing it will work or not. All that goes into the tool.
So, any other? Yeah, please.
सर आपने अपनी ऐप के बारे में बात किया तो मैं हिंदी भाषा में अपनी बात कहना चाहता हूँ। मुझे ऐसा लगता है कि भारत हिंदू यूनिवर्सिटी जो है वो इंडिया में एक ऐसी यूनिक यूनिवर्सिटी है जहाँ पे आज भी अगर इंटीग्रेटेड होते हैं तो मोर देन 145 डिपार्टमेंट हैं, बिजनेस इंस्टीट्यूट्स हैं, सर्किट विद्या संकाय है, लॉ भी है, मैनेजमेंट भी है, प्रशासन भी है। तो क्या सर आपको ये नहीं लगता है कि आपकी BHU मेरे ख्याल से पूरे इंडिया में एक यूनिक पोजीशन रखता है, एडवांटेज रखता है, क्योंकि अगर वो चाहें तो सोशियोलॉजी के 20 प्रोफेसर अवेलेबल हैं, लॉ के 38 प्रोफेसर अवेलेबल हैं, हर डिसिप्लिन में यहाँ प्रोफेसर अवेलेबल हैं। अगर आपको टेक्नोलॉजी डेवलप करना है और उसको स्केल अप करना है, जो आप स्केल की बात कर रहे थे, तो perhaps the IP BHU is the best place to go for this grassroots. यहाँ 40,000 BHU स्टूडेंट्स हैं जो अक्रॉस इंडिया से आते हैं और ये बात सही है कि सर IP मेड्रॉस के जो डायरेक्टर साहब हैं उनका काम क्योंकि मैंने उनके 5-6 लेक्चर सुने हैं और वो बहुत सारी टेक्नोलॉजी डेवलप कर रहे हैं और लेकिन BHU IP के पास एक बहुत ज़्यादा पोटेंशियल है अगर वो ये ठीक है आप बाउंड्री बनाएं।
Thanks for pointing it out. Yeah, I agree with you. If we at IIT BHU connect with we at BHU, it can be a very big plus. It's a unique situation. No other IIT enjoys that advantage. The only problem is that we will need to think big. We need to take up problems that won't necessarily give us a research paper every 3 months. We have to come out. We have to tell, ask ourselves, 10 years from now, what will I be known for? 10 years from now, people will not ask whether you have 30 papers or 40 papers. What have you done? And the answer that I went from 88.3 to 88.7 accuracy is no. Not satisfied with yourself. So think big, be ambitious. And then choose problems which will require interdisciplinary thinking naturally. But they are typically going to take time. But 10 years later, you will be known for what you have done. We have to come out of this short-term thinking. We have to think more ambitiously. To become more ambitious about ourselves, yes, and work on a serious problem. having worked on a grand problem and failed is better than worked on 20 little problems that nobody cares about and became successful in 19 of them. So, you have to come out. It's not easy because rest of the environment has become like that. We have to come out of it. And then we will take advantage of our richness of the environment also, more satisfying also, of working and producing technology which makes a difference.
Okay. Now the time has come to stop. Yeah, if there is no further questions or comments, so let us thank once again Mr. Rajeev for giving his illuminating lecture as usual. And it's like a spellbound magic. Half of the things you have to think later, you may not have understood now. But then that's the message that he has a spellbound kind of articulation and effect on the audience. So somebody has to learn like a Bhashiki, how to also bring out the problem and just discuss so that people go into the depth. He also has given the revolutionary idea, don't think about the paper only. But that is also an important message in the sense that paper will automatically come, paper and patient will come, but once the big vision or big nation is already working in front of us, we should always think on that direction. So with this, my concluding remarks, our director is away, and he, before leaving, he told me that please take care of Mr. Sangal's lectures, discussions, and as long as he is here. So we will say that again, please let us know when we will be coming to visit here. As you said that you feel at home, and that is always to echo that yes, it's also your second home after Tripoli Hyderabad. Thank you. Thank you very much.